Good everyone, I welcome you to another episode of chemistry of metals and non-metal. But in this particular video, we'll be working on chemistry of sulfur, which happen to be a non-metal. So in this video, we are dealing with chemistry of what? Of sulfur. The first thing that will come to your mind is, what is sulfur? We believe that sulfur belongs to group 16 in the periodic table. We have other elements that belong to that same group as well, which is oxygen. And that group is called chalcogens. So chalcogens, CHALCO, chalcogens, and they belong to group 16 in the periodic table. Please take note, the atomic number of sulfur is 16. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur. So the atomic number of sulfur is what? Is 16. While the mass number is what? Is 32. So we can say the proton number of sulfur is 16, the electron number is 16, and the neutron number is 32 minus 16, which is going to give us what? 16 as well. So please take note of this. And another thing again you take note of, everything about sulfur is just 16. First of all, it belongs to group 16 in the periodic table. It has the atomic number of 16, proton number of 16, neutron number of what? 16. And it is the 16th abundant element in the earth crust. We said oxygen is the most abundant, then the one that is in position 16th is what? Is sulfur. So please take note of this. So what about the occurrence of sulfur? Sulfur actually occur in a combined state, in free form, in proteins. Then it occur freely as 0.034% in the what? In the earth crust, as deposit with other elements. So it occur freely in deposit, and the percentage of it is 0.034 weight of the what? Of the earth crust. And in combined state, it actually occur as what? As sulfide. It reacting with another element, a binary compound, which is sulfur plus another element. It's going to give us what? A sulfide. And in some protein as well, sulfur is actually present there. So that is generally about the occurrence of what? Of sulfur in combined form, freely as mineral deposit as 0.034 what? Weight percent of the earth crust. So how do we extract sulfur? Sulfur can actually be extracted in the bonding of sulfur compound. So if you burn sulfur compound, what you are going to get at the end of the reaction is what? Is sulfur. Then some natural compound consists of, or they contain 20% of hydrogen sulfide, and naturally sulfur can actually be extracted from natural gas plant, and most of the plant consists of about 20% of what? Of hydrogen sulfide. It can be extracted in oil refinery. In oil refinery, sulfur can actually be extracted by cracking of hydrocarbon, whereby hydrogen sulfide can as well be what? We produce. Then we have mineral deposits of elements, what I told you the other time. So mineral deposits of elements, sulfur can as well be what? Be extracted. And the process of extracting sulfur is called Frasch process. So let's quickly run through the physical properties of sulfur. Sulfur is a yellow solid. It exists in two forms. We have the crystalline form and the non-crystalline form. So the non-crystalline form usually referred to as amorphous. So the other word for amorphous is shapeless. While for the crystalline form, it means it has a shape. So please take note of that. It is insoluble in water, but it is soluble in CS2. That's for sulfide. Then methylbenzene. Please take note of that. Then it is not a good conductor. As long as it's not a conductor, it's not even good. It's not a conductor generally. So we refer to our sulfur as an insulator. We use sulfur as what? As an insulator. And it is paramagnetic. For those of us who don't understand what is paramagnetism, is that it has unpaired electron. It has unpaired electron. They are not fully paired. Assuming they are fully paired, it is called diamagnetic. But as long as they are not fully paired, it's called what? Paramagnetic. And the melting point of sulfur is 119 degrees Celsius, and the boiling point is 440 degrees what? Celsius. So that is for the physical properties of sulfur. So let's quickly run through the chemical properties of sulfur. The first one we have here, it has 6 valence electrons. First of all, let's draw the share of sulfur. We have 1, 2. Remember, it has the atomic number. Sorry, it has 60 electrons. Let's draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So the first thing that will come to your mind is, how many valence electrons do you have in the atmosphere? Let's count. 1, 2, 3, 4, 5, and 6. So as long as you have 6 valence electrons, you have plus 6. So how many electrons is remaining for this valence share to be complete? We have 2, because we believe that it's going to obey the octet rule. And the octet state that for the share to be complete, how many electrons will be there? Is 8. So we realize that we have to put 1 electron here and 1 more electron here to be complete. So it has an ionization number of plus 6, ranges from plus 6 to what? To minus 2, or minus 2 to what? To plus 6. And another thing again you should take note of is that there are some elements, electropositive elements, such as group 1. Group 1 element is periodable, and group 2 element, which can easily donate electron. They can donate electron to this guy here, to sulfur, and they will form electrovalent bond or ionic bond. And same way, this sulfur here can also share with other elements. The other elements can also come to sulfur here, whereby they are going to share electron. They can share electron here for sulfur to be stable at the end of the whole thing. And in most cases, the elements are usually non-metals. So when they share electron, let's say for example with oxygen, it's going to form a covalent what? A covalent bond. So for electrovalent bond of sulfur is formed between sulfur and electropositive elements, such as group 1 and group 2. While for covalent bond is formed between sulfur reacting with other non-metal. So, and remember, for sulfur to be stable, the octet must have how many electrons? 8 electrons. And for this 8 electrons to be there, it's either it accepts electron, it's either sulfur accepts electron from group 1 or group 2 element, or sulfur share its electron with other what? With other non-metal. So that is for that. So let's quickly rush through the allotrope of sulfur. Like what I said, sulfur actually have 2 allotropes, 2 major allotropes. The first one is crystalline sulfur, while the second one is what? Is amorphous sulfur. Then under the crystalline, we have 2 major ones again. We have the rhombic sulfur and the monoclinic sulfur. The rhombic sulfur and the monoclinic sulfur. Ordinarily, sulfur is rhombic. Ordinarily, sulfur we see, the sulfur you know, is what? Is rhombic. So the one you are going to see is rhombic sulfur, because that is a very stable sulfur. It's more stable than the monoclinic sulfur. And this monoclinic sulfur at 35.5 degrees Celsius, this is when this monoclinic sulfur is stable. So please take note of that. And if you heat rhombic sulfur, it's going to produce monoclinic sulfur. Rhombic sulfur is also called alpha sulfur, while the monoclinic sulfur is also referred to as what? As beta sulfur. So if you heat rhombic sulfur, the product that you are going to see is what? Monoclinic sulfur, which is S8. Both of sulfur is S8, rhombic sulfur is S8, monoclinic sulfur is what? Is also S8. So that's what you are going to produce. And if you cool rhombic monoclinic sulfur, it's going to turn back to what? To rhombic sulfur. So please take note of that. We have angel sulfur, which is S6. We have plastic sulfur, and the next one we have there is what? Amorphous sulfur. But please take note, the 2 major type of sulfur, allotrope of sulfur, is rhombic and what? Monoclinic. For amorphous is a shapeless sulfur, while these are the 2 main type of crystalline what? Sulfur. And please take note, the ordinary sulfur exists in this guy, and at 36 degrees, this is one of the reasons why we believe that rhombic sulfur is more stable than, because at 35.5 degrees Celsius, that is when monoclinic sulfur is actually what? Is obtained. Sometimes you can actually approximate to 36 and others. So any of them that you see, please take note of that. Please take note, this is not 35.5, this is actually 95.5, and here is 36. 96. Now please take note, monoclinic sulfur, rhombic sulfur is actually more stable than monoclinic sulfur. And the only allotrope of sulfur that is stable at a temperature below 96 degrees Celsius is what? Is rhombic sulfur. And monoclinic sulfur is actually stable at this temperature. So please take note of that. It is not 35.5 degrees Celsius, but 95.5 degree what? Celsius. Please take down the correction. Then what about the compound of sulfur? We have hydrogen sulfide, we have sulfur dioxide, we have sulfur trioxide, we have sulfide, which is a binary compound of sulfur. For example, we have H2S, these are sulfide. And we have ozo acid of sulfur. What is ozo acid? Ozo acid means acid that consists of hydrogen, oxygen, then any other element. But as long as you are dealing with sulfur, is hydrogen, oxygen, and what? And sulfur. So any compound that you see of such is called an ozo acid of what? Of sulfur. For example, H2SO4. So these are ozo acid of sulfur. We have H2SO3 and the rest. So they are referred to as ozo acid of what? Of sulfur. So what are the uses of sulfur? Sulfur is actually a minor constituent of certain protein. Uh, uh, that's one. Number two is used for SO2 production, and this SO2, sulfur dioxide, can be used to produce SO42 minus, sorry, H2SO4. So you can use to produce sulfuric acid. It can also be used in the vulcanization of rubber. It can also be used in the manufacturing of fungicide, insecticides, and gunpowder. Please take note. Then it is also used as a bleaching what? Agent in pulp and paper industry. So that is the general overview of what sulfur is all about. If you have any question regarding everything I've explained so far, please feel free to drop that in the comment section. But I have a question for you. The process of extracting sulfur, the process of sulfur extraction is called dash. If you know the answer, please drop that in the comment section. And if the first time of you watching my video, what I do here is I'm just simplifying the concept. I'll give you a general overview of what the chemistry of sulfur is all about. And this is actually the second to the last episode of chemistry of metals and non-metals. Please feel free to drop a comment, on this particular one. And any part of the question, any part of the video that you don't understand so well, please drop that in the comment section. Ask your question there. I will definitely attend to it. Thanks for watching. See you in our last episode.